Hello, everyone. Today we're going to continue proving triangles congruent. And actually, we've learned 4 ways to prove triangles are congruent. Our 4 ways are side, 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 angle, side, angle, and angle, angle, side. We also know that we can't use side, side, angle because it does not work. Now, corresponding parts of congruent triangles are congruent, otherwise known as Cpctc. This is what helps us with the idea that when we know the triangles are congruent, we can prove other things. So, our warm-up. Given that triangle JRC is congruent to triangle HVG, I want to list all the corresponding angles that are congruent and list all the corresponding sides. So please pause and do that right now. Okay, so based on how they're labeled, angle J is congruent to angle H because the corresponding parts have to be in order. Angle R is congruent to angle V. Angle C is congruent to angle G. Then we know that JR is congruent to HV, first 2 letters. Second 2 letters, RC, is congruent to VG. And lastly, the first and third, so JC is congruent to HG. That is the idea that corresponding parts of congruent triangles are congruent. If I know the triangles are congruent, I know all of those things are congruent. So, given AC bisects BCD, and BC is congruent to DC, so BC is congruent to DC, are the 2 triangles congruent? Well, since AC bisects BCD, I know that angle 1 is congruent to angle 2, and I know that AC is congruent to itself because reflexive. So yes, I know that triangle ABC is congruent to triangle ADC by side, angle, side. So that's my congruent statement and the postulate. Now, why is B congruent to D? Well, B is congruent to D because of Cpctc. Corresponding parts of congruent triangles are congruent. So now explain how I can use one of my postulates and CPC to prove each statement. So in number 1, I want to prove that angle A is congruent to angle C. Well, I know that AD is congruent to DC. So that's a side. I know that angle BDA is congruent to angle BDC, all right angles. And that's an angle. And then I know BD is congruent to BD, reflexive. That gives me another side. So that means that triangle ADB is congruent to triangle CDB by side, angle, side. Therefore, angle A is congruent to angle C by Cpctc. So, next problem. It's labeled so that these double angles are congruent to these. This is congruent to this. And then I know HF is congruent to itself. So that means that triangle HEF, so I went double, none, single, is congruent to FGH, because again, I have to do double, none, single, by angle, side, angle. Oops, I said angle, side, angle, but that's not what I wrote. And then HE is congruent to FG by Cpctc. Last problem. So I have J is congruent to N. That's given. JL is congruent to MN. That's given. And angle L is congruent to angle M because they're both right angles. So that's an angle, side, angle. So I know triangle KLJ is congruent to triangle PMN by angle, side, angle. And therefore angle K is congruent to angle P by Cpctc. Corresponding parts of congruent triangles are congruent. So I want you to pause, and I want you to try 4, 5, and 6, and come back and we'll do the proof together. So hopefully you tried these. So I know that QT is parallel to RS. So that means that if I do my parallel sides and my transversal, the angle TQS is congruent to angle RSQ because alternate interior angles of parallel lines. Parallel implies alternate interior. Congruent. I then know angle T is congruent to R because of the right angles, and QS is congruent to QS, reflexive. So that means that triangle TQS is congruent, that's an S, is congruent to triangle RSQ by angle, angle, side, and thus we have the angles we want by Cpctc. When I look at number 5, I have UV congruent to VW, UX congruent to WX, and VX is the same line reflexive. So that means those two triangles are congruent. So triangle UVX is congruent to triangle WVX by side, side, side. And then angle U is congruent to angle W by Cpctc. Number 6, I have angle B is congruent to Y, and I have AB is congruent to AY. I need another fact. Well, the other fact I can get is that angle YAZ is congruent to angle BAC because vertical angles are congruent. So that means triangle YAZ is congruent to triangle BAC by angle, side, angle. And so ZA is congruent to AC by Cpctc. Okay, so we have 3 proofs to do. I'm going to do number 7 now, and we'll start class tomorrow with 8 and 9. So we are given that CA is congruent to CB, and we know that D is the midpoint of AB. What does it mean if D is the midpoint of AB? Well, if D is the midpoint, that means that AD is congruent to DB because the middle cuts it in half. So AD is congruent to DB. Definition of midpoint. We then know that CD is congruent to itself because of reflexive, and that's in both triangles. And now the triangles I want, just to make sure I have what I want, I'm going to draw on them. So I want triangle ACD. So ACD is the blue triangle. And then I'm going to make the other triangle, this green, is BCD. And notice how we colored CD in both colors? That's why I used reflexive. Now that I have all three sides of both triangles, I can say those triangles are congruent. So triangle ACD is congruent to triangle BCD, side, side, side. And therefore I know angle ACD is congruent to angle BCD because those are part of the triangles because of Cpctc. If you have any questions, please bring them to class tomorrow.